Okay, so looking at this first one, it shows where the graph is positive versus where the graph is negative. The graph is positive anywhere it's above the x-axis. It is negative anywhere it is below the x-axis. Increasing versus decreasing. As you walk from left to right, if you're walking uphill, you're increasing. If you're walking downhill, you're decreasing. If you're walking uphill, you're increasing. Okay, the end behavior, we've already talked about end behavior yesterday. As x approaches positive infinity, f of x approaches, in this case, it would approach what? Positive infinity. As x approaches negative infinity, f of x approaches what? Negative infinity. Okay? Questions on that one? So as we look at our first example, again, this is not why I had you guys use your highlighters. I'm actually going to do B before I do A. Okay, I'm going to do B before I do A. You are going to answer for me. When is this graph positive? Where is this graph negative? Where is it increasing? Where is it decreasing? And what is the end behavior? Okay? So let's talk positive and negative. Now, I know I asked you guys to get highlighters out. I'm going to use highlighters up here. Do not use your highlighters yet because I'm going to erase these in a minute. Okay, we said the graph is positive when it's above the x-axis. So let's see. It is positive from here to here. Would you guys agree that's where it's positive? You always define where it's positive based off of the x values. So what is this x value? What is this one? So it's positive between those two x values. Now, right at 1 and right at 3 are the x-intercepts and the value is 0. Is it positive or negative? Neutral. So it's neither. So just make sure you don't include 1 or 3. So what do I mean by that? Well, it's positive between 1 and 3. So 1 is my lower bound, 3 is my upper bound, x is everything between, and so I put less than signs. This says x is everything bigger than 1 and less than 3. X is everything between 1 and 3, not including it. Okay? Where is it negative? Okay? It's negative here and here. Again, you're going to use the x values to tell me where it's negative. Well, it's negative for values of x that are what? Less than 1. And it's negative for values of x that are what? Greater than 3. Do you guys remember this from Algebra 1? You hated it. Okay? We're doing it right now. Again, in Algebra 1. We have a test on this tomorrow. Okay. Are we good so far on positive and negative? Now I'm going to erase all my highlighting because now we're going to switch to increasing versus decreasing. So as you walk from left to right, are you increasing or are you decreasing? You are what? Increasing. So you're increasing until what x value? It's always defined based. Don't look at y, you're looking at x. So it's increasing for values of x that are what? Less than 2. Once you get to 2, then you start doing what? Decreasing. And it's decreasing for values of x that are what? Greater than 2. Okay. Now, the end behavior we should be good with. Remember, and this name is y, so I'm going to say as x approaches positive infinity, y approaches what? Which way is it going? As I go out this way, which way is the graph going? Down. As x approaches negative infinity, y approaches what? Negative infinity is also going down. Questions on B? Okay, now let's go up and get A. And you'll see why I did A second, because I think A is harder than B. Let's do, again, we have positive, negative, increasing, decreasing, and then your end behavior. So positive, negative, increasing, decreasing, end behavior. So you have to be careful on the positive. The positive is kind of tricky on this one. Because where is the graph positive? Well, you guys are like, well, it's positive where it's above the x-axis, right? But be careful. What is it right here? It's 0. Do you guys see that? So we have to do 2. You can't say everything less than, what would this number be? 3? You can't say everything less than 3 because right here it's 0. So it is positive between what numbers first? 0 and 3. So how do I write between 0 and 3? 0 is less than x, which is less than 3. So I did that part. It does not matter what order you put these inequalities in. Meaning, if you put this next inequality in front of this compound inequality, that's fine. Okay. It's also positive for values of x that are what? Less than what? 0. So also positive for values of x that are less than 0. So again, it doesn't matter if you have the x is less than 0 in front of the 0 is less than x, which is less than 3. Does not matter. Where is it negative? It's negative down here. That's values of x that are what? Greater than 3. So x is greater than 3. Are we good there? Okay, now let's do any questions so far? Increasing versus decreasing. As you start walking from left to right, what are you doing first? You're what? Decreasing. You're decreasing until you get to what number? 0. So you're decreasing for values of x that are what? Less than 0. Then you start going what? Up. And you're increasing between what? 0 and, that's all right, I circled that, but that's okay. 0 and what? 2. So you're increasing between 0 and 2. And then what happens after you get to 2? You start going what? Down. So you're decreasing again for values of x that are what? You're decreasing again, for values of x that are not less than, greater than 2. Are we good with that? And behavior, as x approaches positive infinity, this one's called y. Y approaches what? Negative, it's going down. As x approaches negative infinity, so as you go out this way, which way is the graph going? Up. Y approaches positive infinity. Are you guys good there? Now, I wouldn't take off for this, but did you guys catch in your homework last night? Where's the end behavior ones? Where were the end behavior ones? Are they here? Describe the end behavior. Did you catch the names here? So did you catch that I said as x approaches positive infinity, and then I said h of x approaches? Okay. Would I take off if you didn't use h of x? No, but it's, the right math talk to do. Okay? All right. Any other questions here? All right, these next ones, it's just the easiest to show you by doing an example. And the first time I saw this, I was like, how on earth am I going to teach this? I'm going to be honest. But then I got it. I was like, okay, I got this. We're going to use highlighters. And that's why you have your highlighter out. Sketch a graph of the polynomial function f with the following characteristics. F, so the function, is increasing when x is less than 0 and when x is greater than 4, decreasing between 0 and 4. F of x is greater than 0 between -2 and 3 and when x is greater than 5. And f of x is less than 0 when x is less than -2 and between 3 and 5. Use the graph to describe the the degree and the leading coefficient. Whew. Okay, so if you're like me, I kind of went, Here's where you start. Here's where you start. You're going to take your highlighter and you're going to start with these two. Okay? And the first thing you're going to say is, okay, first of all, what does it mean when it says the f of x is greater than 0? That means the function is what? What's a number greater than 0? A positive. Okay? So they're saying that the function is positive here. And then they're saying the function is less than 0 here. That means it's what? Negative. Okay, so we know that positive means it's above the x-axis and negative means it's below. Okay, so let's come to our graph and let's say, all right, we know that this function is above the x-axis between -2 and 3. So between -2 and +3, it is above the x-axis. So I take my highlighter and I say, okay, between -2 and +3, I know I have a positive function. I know I'm above the x-axis. I'm positive between -2 and 3. I'm also positive where else? When x is what? What else does it say? Positive when x is greater than 5. Do you see it says f of x is greater than 0 when x is between -2 and 3 and when x is greater than 5. So here's 5. So that means it would be over here. Okay, so we know it's positive in those areas. That means everywhere else it should be negative, but let's double check this. So let's go through our negatives and make sure I'm good. It says it's negative below the x-axis when x is less than -2. Okay, does that mean it's below the x-axis here? Okay, does that make sense so far? Because you can't have highlighting both places, like overlapping top and bottom. And it says it is negative between 3 and 5. Okay? Between 3 and 5. So, between 3 and 5. So you should not have any positives and negatives overlapping because a function can't be positive and negative at the same time. Now, wherever the graph changes from positive to negative, we had a what? X-intercept. So here, here, and here are my x-intercepts. That's where it was neutral. It changed from positive to negative or negative to positive. So I have x-intercepts at those places where it changes from positive to negative. So I know it has to go through those points. So when I draw my graph, can you kind of see your graph already? We kind of know it's going to go something like that, right? Well, let's see what else it says. It says it is increasing when x is less than 0. So it has to go increasing until I get to what? 0. Does it say how high? No. So it doesn't matter where you put this point. You can put it wherever, okay? I just know that my graph has to increase until it gets somewhere here. And once it gets to that spot, I don't like how I drew that. Once it gets to this point, it's going to what? Yeah, it says it's increasing for values of x that are less than 0. Then once I hit 0, it starts what? And it decreases until I get to what? 4. So, okay, I'm decreasing now, but when I decrease, I got to pass there until I get to 4. So it doesn't matter where you hit 4. And then once I hit 4, what's it start doing again? It starts what? Increasing. So then I'm just going to turn it back up. So it has to cross at those x-intercepts. It has to have turning points where it changes from increasing to decreasing. And behavior, even or odd. Odd. Goes up to the right, positive or negative. When it says describe the degree and the leading coefficient, the degree has to be what? Odd. The leading coefficient has to be positive. We know that. We know that. Okay? Let's do another one of these. Okay. Has it following me? It's increasing here, decreasing here, greater than 0 here, less than 0 here. All right. Greater than 0. We're going to start here and here, where it's greater than 0 and less than 0. What does greater than 0 mean again? Positive. What does less than 0 mean? Negative. So always just kind of think about that. So let's start there. It is positive above the x-axis for values of x that are less than negative 4. So it's above the x-axis for values of x that are less than negative 4. So over here. It's also positive for values of x that are between what? 0 and 5. So between 0 and 5. Never mind. All right, it is negative between what? Negative 4 and 0, so it's negative between negative 4 and 0. And for values of x that are what? Bigger than 5. So once you do that, you can clearly see, okay, looks good. Wherever it changes from positive to negative or negative to positive, those are my what? X-intercepts. Are you guys okay with the first part? All right, now it tells me that it's increasing. It's going up between negative 2 and 3. And it's decreasing when x is less than 3. So I'm going to start with the decreasing because obviously that's where my graph is starting. It's decreasing until I get to what? Negative 2. So it doesn't matter how you start. It's just decreasing until I get to negative 2. Once you get to negative 2, it starts doing what? And it increases until you get to what? 3. So now I'm going to go up and I'm going to make sure I cross here and it increases until I get to 3. So wherever you get to 3 at, your graph might not look exactly like mine as long as it starts turning at 3 again. And then once you get past 3, it starts doing what again? And make sure it goes through that x-intercept. Now, talk to me about your degree. Has to be what? Odd and what? Okay. What do you guys think about this? Easy, hard? Yeah, I don't think it's that bad. Would you say fun? I agree. it's too bad. Something different. Some of you are like, I don't know if it's fun, Mrs. Naples, but all right. Last one. The African wild dog is the most endangered carnivores on Earth. Its estimated population of the African wild dog under human care can be modeled by this polynomial function, where t represents the number of years after 2000. Use technology. When it says use technology, this is where you may what? Graphing calculators. Grab the graphing calculators. Use your graphing calculator to graph the function when t is between 1 and 18. Now, guys, t is the same thing as what? What are we going to use when we put this function into our calculator? We're not going to use t. We're going to use what? X. Okay, so really they're saying when x is between 1 and 18. So let's go ahead and put this function in. So 0.368x to the third minus 11.45x squared plus 109.5x plus 286. Now, guys, if I do Zoom 6, let's think about this graph for a minute. If I do Zoom 6, I'm not going to see anything. Because where is the y-intercept on this graph? Let's talk about this graph. Where is the y-intercept? 200 and what? 86. So if you do negative 10, 10 by a scale of 1, you're going to see that little bit of the window. Okay? So we are going to need to adjust our window. So I'm going to go to my window. I'm going to leave x at negative 10. That's fine. But what should I change x max to if I need to make x out to 18? 20. Okay? And you might want to go by a scale of 2s just so it doesn't put a whole bunch of dots along the way. How about the y? I'm going to leave negative 10. That's fine. But what should you guys go up to? Well, it's going to go at 286. Is it even or odd? Odd. Okay. Is it positive or negative? Positive. So it's eventually going to go up further to the right, correct? Yeah. So we are probably going to get something that, we don't know. And we know it's going to kind of do something like this, right? Yeah. So we know we have to go higher than 286. If you just put 286, you might only see like this part of the graph. So I'm going to tell you just because of experience, and since we had that our little survey we had to do earlier. Let's go to 1,000. And this would be a trial and error until you could see the whole curve. And I don't want to go by a scale of 1s. If you guys were making a graph up to 1,000 by hand, what would you put every tick mark at? 100? Okay. So here's my window that I chose to use and graph. All right, and that's kind of what we got, what we expected to see. A graph that has odd degree, positive leading coefficient, goes up to the right. Here's my scale. We know these go by 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These go up by 100 to 1,000. Describe the graph as you go to 18. Now remember, 18 is here. 1 would be here. So describe the behavior of the graph. So what happens to my graph in the beginning? At first, the graph is what? Increasing. So the number of dogs increases. Then what? What's it do slightly after it increases? It decreases slightly. And then what's it do again? And then increases again. Okay, so something had us trailing off a little bit there in the middle. Did I describe the behavior of the graph over the interval from 1 to 18? Okay. Find the average rate of change from 2001 to 2018. Guys, what is X or T in 2001? If T is the number of years since 2001. What is X or T in 2018? All right, let's find what those values are. Second, calc, value. What do I want X to be in the first one? Second, calc, value. I want it to be 1. And when I do, I get, it's the 384.418. Okay, let's do it for 18. Second calc, value, how about in 2018? What did you guys get? We got 693.37. What's another word for rate of change? I know it's not a line, so it's kind of like, I don't like, but rate of change is, let's say change in Y over change in X. Have you guys ever heard delta Y over delta X? That means change in Y over change in X. So let's find the change in Y. You're going to do 693.376 minus 384.418 over 18 minus 1. Well, what's 18 minus 1? So you're going to take your calculators and subtract, and you should get 308.958. And when you divide by 17, you get 18.174. Is that a positive number or a negative number? So that means the rate of change is about what? About 18 dogs per year. So that means we're going up 18 dogs per year. Last question. Okay. What about, do you think this is a useful model for years after 2018? All right. Well, since it is an odd and it's a positive, we know that this would keep doing what? Do you think the number of dogs would increase forever? No. They would probably what? At some point, they would probably what? Level off or decay, either way, okay? Or level off. So since it's odd and positive, I would say no, not a good model. Will not continue or will not grow forever. Okay, questions? Awesome. All right, that survey took a smidge of time for us. Have a fantastic day.